Hey everyone, have you ever stopped to think about how your phone knows it's you? Or how a self-driving car can navigate a busy street? Well, today we're going to pull back the curtain on the technology that makes it all possible. We're talking about how we teach computers to see.
I mean, it really comes down to this one big question, right? How do you teach a machine that only gets ones and zeros to understand the world the way we do, with all its color and complexity? Well, the answer is a really clever piece of tech that we're about to break down. And here it is. Meet the convolutional neural network, or CNN for short. You can think of it as a special kind of artificial brain, one that's an absolute expert at finding patterns. And you're going to see that vision, at its core, is all about recognizing patterns. Okay, so let's start with the basics. What exactly is a CNN, and what makes it so darn good at what it does?
Honestly, if you remember one thing, it's this. A CNN is a machine built to detect patterns. An image is just a collection of edges, shapes, colors, and textures, right? Well, a CNN is designed specifically to find those things, from a simple straight line all the way to a complex object. That's its superpower.
So, how does it get that superpower? What makes a CNN different from any other kind of neural network out there? The whole secret, it turns out, is in one very special component.
See, a regular neural network, on the left, just has these generic hidden layers, but a CNN, over on the right, has these special convolutional layers right at the beginning. This is the secret ingredient. This is what changes the entire game.
And these layers don't just pass info along. They're actually doing something to it. They're transforming the input using a mathematical process called convolution. And that's exactly what we're going to dig into next.
All right, so inside those special convolutional layers, that's where we find the real heroes of this story, these little pattern detectives that we call filters. Now, a filter sounds fancy, but it's really just a small grid of numbers. But here's the cool part. Each filter is trained to look for one very specific thing, maybe a horizontal line, or a curve to the left, or a sharp corner. They're like these little detectives, each with their own specialty.
And it all works in this really cool hierarchy. The first layers in the network have filters that find really simple stuff, edges, corners, basic shapes. Then the next layers take those patterns and combine them to find more complex parts, like an eye or some fur or maybe a feather. And then finally, the deepest layers put those pieces together to recognize the whole shebang, a dog, a cat, a bird. It's kind of like building with Legos, right? You start with simple little blocks and build them up into something amazing.
Okay, so we've talked about what these detective filters do. Now let's get into the nitty-gritty of how they do it. And don't worry, it's actually simpler than it sounds. We'll just walk right through it.
So for our example, let's use a handwritten number 7. Now for a computer, this isn't a 7 at all. It's just a grid of pixels, where each pixel has a number that tells you how bright it is. This is our input data.
And now, our little detective, that 3x3 filter, gets to work. It starts at the top left corner of the image and lays itself over the first block of pixels. This sliding movement is what we call convolving.
And at every single spot it stops, it does a really simple piece of math. It just multiplies its own numbers by the pixel values it's sitting on top of, and then it adds all those up to get one single number. That's it. That's the entire operation.
So that one number we just got, it becomes the very first entry in a totally new grid. This new grid is our output, and it's basically a map showing us where the filter found the pattern it was looking for.
Then the filter just slides one step to the right, does the exact same calculation, and puts the new number in the next spot on our map. And it just keeps doing this. Slide, calculate, record. Slide, calculate, record. All the way across the entire image until it's built a complete map of where its pattern exists.
So what's the point of all that sliding and calculating? Well, this is where the magic happens. This is how we go from doing simple math to actually, seeing.
Okay, so let's bring back our original handwritten 7. Now we get to see what those pattern detectives actually found when they scanned this image.
Check this out. This is the map from a filter that was trained to find top horizontal edges. And would you look at that? The brightest parts of the map line up perfectly with the top bar of the 7. The filter is basically screaming, "Hey, I found the horizontal line right here." Now here's a map from a totally different filter. This one was looking for vertical lines. And again, it's a perfect match. The brightest spots trace the main downward stroke of the 7. You see? Each filter is only interested in its own special pattern. And here's one more. This one's for diagonal lines. It lights up right where that diagonal stroke in the 7 is. So now we have these 3 different maps, and each one is highlighting a different fundamental feature of our number.
This really says it all. When you're looking at these output maps, just look for the bright spots. That's the filter telling you, loud and clear, this is where I found the thing I was looking for.
And this right here is the key. The network doesn't just look at one of these maps, it looks at all of them together. It learns that the pattern for a 7 is the combination of a horizontal top plus a long diagonal stroke, all arranged in this specific way. It's building a complete understanding from all these simple little pieces.
Which, brings us to a final, pretty big thought. We just saw how these simple little grids of numbers can learn to see a handwritten digit. So, if they can learn to see edges and shapes and objects, what else can these powerful pattern detectors learn about our world? It's something to think about.